Dear students, today we are going to start chapter 2, which is measurement and experimental techniques. So let's get started with lecture 1. First of all, SI units. What are SI units? The International System of Units means these units are used internationally, not at national level. At international means at all countries. They are bound to follow SI units to measure quantities of different things. And why SI units are used? It is used in order to communicate scientific information easily. Scientists all over the world use SI unit as a common standard for their measurement. So why they are using internationally SI units? To make it common means at all countries they are bound to follow SI units. If a research takes place, then they have to measure the quantities in SI units. So, let's talk about measuring time. In the laboratory, a stopwatch or stop clock is used to measure time. The SI unit for time is the second. Okay? Second. But if longer interval of time, then minutes and hour can be used. But the SI unit for time is second. So, to measure time in second or in minute or hour, what could be used? Analog stopwatch or digital stopwatch. Both are handheld timepiece designed to measure the amount of time that elapses between activation and deactivation. Next is our measuring temperature. In the laboratory, the mercury thermometer can be used to measure temperature. The SI unit for temperature is Kelvin. Okay, so scientists are bound to follow SI units. Another unit for temperature is Celsius. How could we interconvert Celsius into Kelvin or Kelvin into Celsius? A simple formula. If you need to find temperature in Kelvin, then temperature in Kelvin is equal to temperature in Celsius plus 273. Means if your room temperature is 28 Celsius, then how many Kelvin is it equivalent to? Then you have to add 28 plus 273. So you can calculate temperature in Kelvin. As I told that commonly in laboratory to measure temperature, mercury thermometer is used. How it look like? This is a mercury thermometer. It can measure temperature from minus 10 Celsius to 110 Celsius. And how it is accurate? Its accuracy is plus minus 0.5 Celsius. Next is temperature data logger. Here a digital device is connected with temperature sensor. So this sensor, you could dip this sensor into a solution of which you need to measure temperature of if there is a system in which temperature is regularly changing, so you could use temperature data logger because it has temperature sensor which digitally represent temperature of that solution. So a temperature data logger, also called temperature, is a portable measurement instrument that is capable of autonomously recording temperature over a defined period of time. You could feed that how long you want to measure the temperature, for an hour or 2 or 3. A data logger is commonly used to monitor shipment in cold chain and to gather temperature data from diverse field conditions. So its importance. The next is how to measure mass. To measure a mass, beam balance is used. Another thing to measure balance is electronic balance, which is commonly used in nowadays. This is commonly used in chemistry laboratories. SI unit for mass is kilogram. Okay, but as you know, in chemistry the masses are much smaller than kilograms. So electronic balance accuracy is up to 0.01 gram. Next one is how could you measure volume? To measure a volume, there are different equipments. But first of all, what is the SI unit for volume? The SI unit for volume is cubic meter. To measure a volume, you can use beaker, which look like this. You can also use measuring cylinder. Measuring cylinder is much more accurate than beaker. It measures up to the nearest centimeter, example 99 centimeter. You can also use burette. It is also more accurate than beaker. Accurately measures out the volume of a liquid to the nearest plus minus 0.1 centimeter cube. Scale marked in 0.1 centimeter division. There is a marking of 0.1 centimeter divisions. The next one is pipette. Student most probably confused with its spellings. PIPETTE. Okay, please memorize the spelling of pipette. Again, it is more accurate than beaker, measuring cylinder, burette. It is most accurate, and you can measure liquid of 20 centimeter cube or 25 centimeter cube. Okay, how should we read the volume of a liquid? There are two possibilities, that a liquid make concave meniscus or a liquid can make convex meniscus. So two possibilities. Now what to do? First of all, what is meniscus? Solution when placed in glass container will form a curve. It could be concave or convex. Okay. If the meniscus is concave, read off the scale at the bottom of the meniscus. If it is concave, then at the bottom. If the meniscus is convex, okay, read off the scale at the top of the meniscus instead. So if concave, then bottom, concave, then bottom, and if convex, then top. Let's do an example. So what you look in this picture, you can see that liquid is making concave meniscus. Concave, the shape of concave is like this. So how you can read the burette or a pipette reading? How? The accurate one is this, to be at the level of the meniscus, not above, not below, just as level. And what you have to read? The bottom of concave. So That's all for today. There is an assignment to you. You have to write that 1 liter is equivalent to how many milliliters, and second one is 1 liter is equal to how many cubic decimeters, and the third one is 1 cubic meter is equal to how many liters. So I am repeating the question. 1 liter is equal to how many milliliter? 1 liter is equivalent to how many ml? Okay, how many mLs? The next one is 1 liter is equal to how many cubic decimeter? Means 1 liter is equal to how many dm cubes? You have to solve this. And last one is 1 cubic meter, centimeter cube, or you can write m cube, is equal to how many liters. So that's all for today.